Dr. Fredrick retired from the United States Department of Justice after 20 years as an expert witness in federal criminal proceedings and issues of competence to stand trial and criminal responsibility. Only one of the reasons why he's here today. He also spent 20 plus years as a psychologist in the Navy. Thank you for your military service and all others. Thank you. He's currently in private practice after retiring from both of these former careers, so we still get his expertise. In 1996, Dr. Fredrick became board certified, and he has long been involved in both the American Board of Forensic Psychology, our credentialing board, and the American Academy of Forensic Psychology, which is our continuing education board. He developed the websites that are still in use for both boards. He promoted the development of faculty of examiners within the ABFP to increase consistency of the examination process. This is quite an improvement. He promoted the development of forensic competencies to articulate what professional psychological practice constitutes. Dr. Fredrick re-standardized the written examination for the American Board of Forensic Psychology. We still have a page and a half to go. As the national chair of examinations and the president of ABFP, he promoted the development of a fully transparent model of candidate examination. Dr. Fredrick has served as co-chair of the continuing education for the AAFP since 2008, along with Dr. Randy Otto. And this is where I enjoy kind of working as an extension with Dr. Fredrick most. He and Dr. Otto effectively develop, organize, and oversee 50 to 60 full-day workshops in forensic psychology each year. And if there's anyone who can speak to how much work goes into that and knowing what they do, it's me. And so thank you very much for doing that. Dr. Fredrick has also presented workshops on the assessment of feigning mental disorders in over 70 venues, including the United States, Canada, Europe, Australia, and New Zealand. He's been the primary author of 2 books on case law, criminal competency, and criminal responsibility. He's been the primary author of numerous book chapters and peer-reviewed papers concerning forensic assessment, particularly the assessment of feigned cognitive impairment. In 1997, he published the Validity Indicator Profile, a test designed to assess feigned cognitive impairment. The VIP is a test in worldwide distribution. And I'll never forget a webinar that you gave to the Center for Forensic Psychiatry when he explained to us, this kind of came to him and he developed it on his drive home from work. And I believe him. His main research interest is in solving problems and using classification tests to evaluate feigned cognitive impairment, especially by the use of simultaneous use of multiple methods. And that is the topic on which he will speak today. So, Dr. Fredrick, on behalf of the AAP, congratulations on your award.
I just want to start by saying I'm very pleased to be a member of the American Academy of Forensic Psychology. Not for the accomplishment of getting board certified, but because of the opportunity to be involved with so many people who care about things that I care about, which is good forensic practice. And really, I really enjoy being able to communicate on a listserv with people whose primary goal is to do good forensic work. I want to just make some acknowledgments here. I'll start with a picture that shows that I once had hair. But Dick Rogers was the first recipient of this award, and Dick is here, and good to see him. Dick is really the person that I believe has done the very best work, especially on the conceptualization of how you diagnose or classify malingering and the problems inherent in many of the bad models out there. He consistently has very good instruction on how to approach this issue. And I think the thing that I admire the most about Dick in this matter is his emphasis on a very low false positive rate in the classification of malingering. And that's not always true. I think if you look at neuropsychology today, people are quite willing to have quite high false positive rates, and that's quite a problem. There's two people that have been my mentors in my career that are not able to be here today. But Dave Murat, a person I worked with for a long time at the U.S. Medical Center, and Alan Goldstein, who, if you don't know, you need to get around more. But both of these are people that I want to be like, and have been a very good model for me in my career. Colleagues that I work with and publish with, and have done many things with, include Rick Demir, my colleague at the Medical Center for 20 years, Randy Otto, here that we have worked for a long time together on many things, including for the past 8 years on the CE workshops for the Academy. Ross Crosby, you probably don't know, he's an experimental psychologist. He was my personal research psychologist for a year at Pearson, and it was just a tremendous experience to be able to get him to do anything. And then Dan Neller sitting here on the front, a very valued friend. Good to see you, Dan. I want to just talk about the problem that I see going on in this field currently, which is the use of multiple malingering tests. I'm just going to start with just an overview of what is the process of using classification tests to detect malingering. And so essentially what happens is that somebody gives a test, and then based on the score, you're either classified as a faker or a non-faker. And there's really no continuum here. People say you're a faker, you're not faker. That's what a classification test does. It's not like an MMPI score on depression. How much depression do you have? A classification test is what I'm interested in, and how you make decisions with classification tests. There are some restrictions for the use of these tests, which we would call assumptions. And the first is that there have to be two groups. If there's more than two groups, you have a lot of problems. You can use classification tests with more than two groups, but that's not the problem as most of us see it currently. You have to know the base rates at which the groups occur. And so we would call the base rate of fakers, and we'll just say fakers or feigners. There are many different terms that you can use, but we'll just call that the P of F, the probability of faking or feigning, and then the complementary probability, because there's two groups, is a P of not F, okay, not faking. And those add up to be 1. So that's all of the people that we encounter with our test. You're either faking or you're not faking. We're going to call you one or the other. The third assumption that we have is that there have to be valid tests that classify the two groups with a known error rate. And especially if you work under Dalbert, if you work in a Dalbert state, then one of the requirements is that your methods have to have known error rates. And this, I think, is probably the biggest threat to validity for the use of these tests, is that the validity rates are not really well known or understood. If the three assumptions are met, then you can change the probability of feigning. And what I mean by that is when somebody comes into your office or somebody comes into your clinic, they have a probability of feigning already when they come in there. What your job is to do is to change that value by some form of assessment. Otherwise, you should go back to Millian sort of statistics where you just call everybody the most likely outcome. Everybody's not faking, and so that's what you always say, and that's where your highest accuracy rate exists. You're going to introduce some method to change the value of P of F in a way that leads to some decision about group membership. So we'll just start with the assumption there's two groups, and then we're going to say that we know the base rates of these two groups. And I've written quite a bit about this. I would say this, it's probably not that hard to determine what the base rate is of the groups that you work with. It's pretty easy to do if you use a test consistently, and I'll show you later on in the lecture if you're not familiar with this idea. But if you use a test consistently with folks that has a reasonably stable true positive rate and false positive rate, it's not hard at all to establish the base rate of feigning in your clinic as the P of F that you start with. But there's many other ways to do this as well. But the point is, why are you using a classification test if you don't already have some value in mind? I mean, this is a point that people often miss, is you're using a classification test because you already have some value in mind and you want to change that value by the use of the test. Okay, so now I tend to use a lot of math, but what I've learned in speaking to attorneys is that if you put pretty pictures in, it helps quite a bit. So I'll put some pretty pictures in here that will sort of help along. But I will tell you this, we talk about the probability, and I don't know about you, but I find probability very easy to talk about, the probability that something's going to exist. But I want to talk to you about a methodology today that involves converting the probability value to odds. And I don't understand odds at all, okay? I don't get it. It doesn't communicate to me. I'm not empathic with it. My emotional response is negative. I don't get it. And so what I want to tell you is that you don't need to understand odds, okay? You don't need to know how to talk about odds, because odds and probability are equivalent ideas. A probability can be expressed as odds. Odds can be expressed as a probability. And so we'll just look at here. If we say that the probability of feigning, so what forensic neuropsychologists say is the base rate of feigning in their forensic neuropsychological evaluations, which is the area that I'm most interested in, is about 40%. About 40% of the people that come into the clinic for an IME or for some sort of evaluation, they're feigning. And so what are the odds that they're feigning? The odds are 0.67, and the way you do it is simply to take the probability and divide it by the probability of not F, okay? The probability of F divided by the probability of not F is going to be your odds, 0.67. And what that means is for every one non-faker, there's 0.67 fakers, okay? So more non-fakers than fakers. Use Excel, okay? I have a little Excel program that just changes everything from probability to odds, changes everything from odds back to probability to me. I don't have to understand odds at all, except when I program Excel, okay? You just have Wikipedia open on one screen, you have Excel open on the other screen, and you can figure all this stuff out. Okay, now I just will make this statement. If your probabilities, your pre-test probabilities are close to 0 or 1, why are you giving a test? A test is not going to help you. Let's say, is there a good screening classification test for multiple personality disorder or dissociative identity disorder? I mean, the base rate is so low that every positive score is going to be a false positive. Okay? Every positive score is going to be, why are you giving it? If every positive score is going to be a false positive, why would you do that? So you want to work with samples in which the probabilities, like are 5, 10% or higher. And I don't think you're going to work in a sample where there's 95% people faking. Okay, and then I think you just need to relax your mind a little bit and think about, what does this mean, the probability of feigning is 40%? Many people think, well, that means that 40% of the people that you're encountering are faking. And what I would encourage you to do instead is to start thinking of everybody you see this way. They have a probability of 0.4. Now, some people say, well, that doesn't make any sense to me that their probability can be 0.4. But the idea is you want to change P of F. You want to start out with P of F equal to some value that represents a probability, okay, of where this person belongs. This person is mostly a non-faker, but partly a faker. And you can say, well, they're either 0 or 1. Well, in the end, you're going to put them 0 or 1, but when you start with them, it's better to think of them this way, in my view. And what you're wanting to do is to give a test that changes them from this into either this, highly likely to be a faker, or highly unlikely to be a faker. And this is a good test. If you have a test that does this for you, you have a very nice test. Okay, so you want to change that P of F value in some way that then you say, well, yeah, this person has many characteristics that suggest to me that they're feigning, and that's going to be my decision. If you want to ask what the reasonable psychological certainty that I have in doing this evaluation, my conclusion is that they are, or this person is not. Do they have some characteristics of feigning? Yeah, they do, but you know what? The overall view I have is the probability is very low. Now, the way that you really think about this sort of thing is this, is that people in this group that, their individual probabilities are 0.9 as a group. 9 out of 10 are faking, okay? 9 out of 10 people with these characteristics, whatever they happen to be, test scores or whatever, 9 out of 10 of them are faking, and so you then do the dichotomous classification at the end and say, okay, 9 of them are, 1 of them isn't. That's what it means to have a probability equal to 0.9. Same thing for 0.1 here. So how does this work that we're going to talk about today? What we're going to talk about today is how you change the probabilities, and the way that I think about things is that you really ought to have something practical that you can do. So let me just stop and make a comment here. I have an Excel file. I use Excel all the time to solve problems for me. Anything that I refer to today, you are welcome to write to me and say, hey, send me your Excel file. I'll be glad to do it. I'll be glad to coach you on it. Anything at all. I have some Excel files on my website that you just download and use because they're very helpful in thinking about things. I don't have any interest in making a buck off you. What I'm interested in is us thinking clearly about what it is that we're doing. So you start off with the pre-test probability, which you use Excel to convert to pre-test odds for you. Then you're going to give a test. Now, based on the characteristics of the test, and I'll just tell you the two characteristics are the true positive rate and the false positive rate. Based on those characteristics, you get something that's called a likelihood ratio. You don't have to understand likelihood ratios because you can get Excel to do everything for you, okay? And it's good to understand what a likelihood ratio is, but it doesn't have to scare you, okay? And multiplying the pre-test odds by the likelihood ratio gives you some post-test odds, which you then convert to a post-test probability. Okay, or you can use multiple tests. And what happens here is you start with pre-test odds. Every one of these tests has some likelihood ratio associated with it. You multiply everything by the pre-test odds, and then you end up with some post-test odds. How does that work? It really works like this: is you start out with pre-test odds for test 1, you multiply it by the likelihood ratio for test 1, you get your post-test odds for test 1, which becomes your new pre-test odds for test 2. Then pre-test 2 gets multiplied by the likelihood ratio for test 2, gets your post-test odds for test 2, so on and so forth. How many tests could you possibly have? I'm going to show you some examples today where people have 23 or 24 tests in their assessment. 23 or 24. That's what they bring to court, okay? I'm not saying it's a good idea, it's just what I encounter, okay? So what can you do anything about it? No, I just want you to understand, so I just keep explaining the same thing over and over. What these little pictures mean of the ink blot is that there's some likelihood ratio. And what it really turns out to be true is that there's 2 different likelihood ratios for each test. A test has a positive likelihood ratio if the test outcome is positive. So if you take the TOM, the test of memory malingering, right? Take the TOM, you fail the TOM, there's a positive likelihood ratio. That value is 24. Okay, so you multiply your pre-test odds by 24 to get your post-test odds. If they pass the TOM, well then the pre-test odds are the negative likelihood ratio is then multiplied. I forget what it is, but it's some low value less than 1. Okay, so any negative likelihood ratio has a value less than 1. When you multiply your odds by that negative likelihood ratio, the odds decrease, right? If you have a positive likelihood ratio, the values are greater than 1 and the odds increase. And so what you're really going to do is this, is you're going to find out which tests were passed and which tests were failed, and you're going to multiply your pre-test odds by a negative likelihood ratio, a positive likelihood ratio, a positive, a negative, and a positive. Okay, and then that will give you your post-test odds. Okay, does this make sense? Okay, good. Okay, I don't own any stock in Microsoft. I just tell you this, I don't like Microsoft. I don't know if you do, but I hate Microsoft. But I'm bound to PC by the fact that that's what I bought, and I can't understand Apple, okay? Well, I will tell you this, Excel and PowerPoint have turned out to be very powerful tools. You have to give them credit for making some very powerful programs. Now, you can't read this, but what I just want to show you, this is my Excel file, okay? Now, you can't read it, but I just want to show you this is what it looks like. This exists. This is what I have that I pull up. I get a report from somebody, and what I do is go in and populate this Excel value with passes and fails based on the test data that I see to get a likelihood ratio that takes a pre-test odds to a post-test odds. Now, we're going to look at this in parts. And what's in the Excel file would be a test that somebody gave. They gave the B test, or they gave the TOM, or they have the advanced clinical systems. There's all sorts of effort modules on the advanced clinical systems. And then I have a cut score that is recommended by the author or used, or is the best cut score that I have seen based on the review of the literature. And then in my Excel file, I then cite what that paper is that has that cut score. Based on that paper, I then report, or I have in my Excel file, what the true positive rate and false positive rate for those tests are. Okay, so this is just research. This is just getting in there and finding the papers. You know, the current popular book for neuropsychologists, I believe, is by Schutte and Ord. Don't hold me to the name, but I mean, it has a whole chapter with nothing but these values in it for 50 embedded measures of malingering, okay? And we'll talk, embedded measures of malingering are something like reliable digit span. Reliable digit span isn't a freestanding test. It's part of the Wechsler Adult Intelligence Scale. You give digit span, and then if you know what you're doing, you can use digit span to make an effort assessment. It's an embedded element of the Wechsler scale. So this chapter in Schutte and Ord has 50 tests that they show have some capacity to evaluate effort. Now we'll talk later. I don't really know that the neuropsychologists have correctly identified the construct they're working with. I think they mismatch constructs sometimes. I'm not crazy about this discussion of effort all the time, but that's what it is. And you can go in and find, you find something like failure to maintain set on the Wisconsin card sorting test, and then you can discover there's a lot of literature on that. You can go and review that literature and decide which papers you think best describe the test characteristics. Okay, then you're going to record the score. So let's look at this one, E-score on the B test. This person got a 41, that's a pass. And you see they have a negative likelihood ratio less than 1. Okay, so that's going to decrease the odds. And just a little bit bigger, these are the test and the cut scores. These are the true positive rates and false positive rates. And then here's my column of likelihood ratios. And you see if I don't use a test, we just have a 1 in there, because if you multiply 1 by anything, it's just the same value. So if you didn't use a test, it's going to be multiplied by 1. You don't have to do anything with your Excel file except go in and identify which tests were failed and which were passed. And then it will multiply all the likelihood ratios for you and come up with some value here, okay? And so the likelihood ratio here that gets multiplied by the pre-test odds is 0.0004 based on the 24 tests that this person was administered. Does that make sense? There are 24 tests. You go in and get 24 likelihood ratios based on their pass or fail rates. And this is the value that you're going to then multiply by your pre-test odds. Very, very low likelihood of faking. If you call this person a faking, you might be a biased witness, okay? You might be biased. Okay, so then I just have a little table that automatically populates as well and tells me all the possible values I might have used for pre-test probability and what the values are for post-test probability. And will I send you this Excel file if you ask me for it? Of course I will, okay? I would love for you to become a person who uses something like this in your own analysis of multiple measures of malingering. Okay, so I just want to talk about why this is an important issue. It's an important issue right now. If you follow the neuropsych literature, you'll see in the clinical neuropsychologists there's a current debate going on about how many tests must you fail to be a probable malingerer. And the current idea, 2. Okay, and I think this is absolutely incorrect. Okay, might be 2 if you gave 2 tests. If you give 24 tests, not so much. Okay, 2 isn't a very big number when you give 24 tests. So these are some actual reports, and you shouldn't be able to identify who the neuropsychologist was, but I just want to start with a general idea. I see this often in these reports, that I gave some effort test, and then this is a statement: persons who give good effort almost always perform normally. See this all the time. I just want to tell you right now, it's a false statement. Couldn't possibly be true. What is true, and again, I'll go back to what I said about Dick to begin with, his emphasis on a low false positive rate. That is not the general consensus of neuropsychologists today. Okay, they don't have a consensus that you should use tests with low false positive rates. I'll show you one in a second that's used commonly. The false positive rate for that test is 13%. Okay, now think about giving 24 such tests. I wonder if you can begin to see what the problem is in saying that persons who give good effort almost always perform normally, meaning they get no positive scores. Okay? Now it's followed by a statement: none of these scores are positive, and this is what they don't mean by this. It just means that probably none of the obtained scores were positive, were indicative of faking. But what they didn't say is this: they didn't say they showed good effort. See, they didn't say the positive attribute of passing all this test. Very common problem. Now, all of these reports are from people who routinely work for defense, meaning insurance companies, okay? And so they don't say, hey, this is good evidence of good effort. They just say they didn't fail any of the tests. Next paragraph, okay? Next paragraph. Here's one. On the Connor CPT, how many people knew that the Connor CPT was a malingering test? Has several measures of effort on it. Several measures of effort on it. And then what I want to show here, and I want you just to get to thinking about this and to be alarmed by it, they gave one test, they were reporting on one test, and based on the one test, what are they doing? They're making a statement about P of F. You with me? Based on one test, they're making a statement. People who score like this have a probability of fainting greater than 50%. What do they say in their next paragraph? Oh, this probability of occurring in this sample is less than 6%, so meaning probability of F is 94%. And what you will see commonly is just a report peppered with these statements every time there's a positive score. Every time there's a positive score, it's followed by a statement about P of F. So what I'm saying is there's no effort to combine test scores, to look at the whole picture. Now, there are some people who have started doing what I'm going to talk about today, or have been talking about, which is chaining likelihood ratios. They report 7 tests here that were failed, embedded measures and freestanding tests. 7 tests were failed. This person changed the likelihood ratios for each of those tests. Each of the likelihood ratios is positive. And what do they say? This yields a probability of malingering exceeding 99%, which I'm going to guess they're going to say the person is faking, okay? They don't need it to be any more certain than 99%. Now just think about that. Would you feel comfortable writing a report in which you say the probability of fainting is greater than 99%? I'm absolutely certain, okay, that this person is faking. What happened was that this person chained all the positive outcomes. But what's supposed to happen is this. They're supposed to chain the negative outcomes with the positive outcomes. Does that make sense to you? That's what they're supposed to do. They're not supposed to cherry pick, and this is what I often refer to in deposition. What this person is doing is cherry picking. They're picking out all the positive scores. They're then chaining I'm telling you, this is based on some work by Larrabee of 2008. I'll show you what the problem is with that paper in a second. But people pick up on this and they say, well, let's start doing it. But what they're doing is they're just picking on the positive scores, and they're not doing this analysis where if the test was passed, That's a negative likelihood ratio, okay? So this person gave 24 tests. I put all the likelihood ratios into my Excel file. What's the outcome? The likelihood ratio was 3 in 10,000, 4 in 10,000. Multiply that by your pre-test odds, okay? And then the P of F is something 3 in 10,000. Now this was just, I'm going to tell you how this case resolved was just an email to this very aggressive trial attorney. I said, okay, I've looked at Dr. So-and-so's report, I've reanalyzed the data, and the outcome is that based on his methodology, based on his or her, I don't recall who it was, his or her methodology, based on his or her data, the probability is 3 in 10,000, okay? When it's applied properly. And the guy calls me within a week, hey, it's all over. The insurance company just walked away, made a settlement, said, look, forget about it. They had a psychologist, neuropsychologist, going to come to court and say 99% probability of faking. But when you expose bad methodology, they don't want that because they don't want to lose, and the truth is they don't want to lose that expert in future cases, okay? So, all right, so this is Larrabee's article in 2008, and what Larrabee, I don't know Glenn Larrabee, as far as I know he's done very fine work, but there's a problem here in what he did in this 2008 paper. What he did is he took 5 tests, very common sort of methodology. We're going to take 5 tests of malingering, we're going to give them to these people, and we're going to see what the outcomes are. And then what he says is this, is if you get 1 positive score, 80 to 84% likelihood of feigning, depending on what the score is that they failed, okay? If you get 2 positive scores, 94 to 97% probability of feigning, and 3 positive scores, almost certain. Now what he did is he did cherry picking again. He only looked at the positive scores. And so if you add the 4 negative likelihood ratios and recalculate the probability of feigning, it's 10 to 31%. What has happened in the last 7 years, however, when people have given, you saw the first 2 reports I showed you where people say that this is associated with 50% likelihood of faking, 94% likelihood. That's where they get this information. Okay, so if they fail 1 positive score, 80 to 84% likelihood of faking. In actuality, when you give somebody 5 tests and they fail 1, it's a 10 to 31% probability of feigning. Okay? Same thing for the other 2. Now, I have an Excel file that does a simulation for me. It does 10,000 people every 5 seconds, okay? So you just push a button and you just resample 10,000 people, whatever base rate you want, okay? It took a few hours to make, but it's so much fun just to sit there and do that. Endless source of amusement to me, okay? It works great to see that the calculations are correct, that when you give the 5 tests to people over and over and over, this is what turns out to be true, is the values aren't anything like what he said for 1 or 2 positive scores. Now, how many people are familiar with the SLIC criteria in neuropsychological assessment? The SLIC criteria, 1999, as I often say in depositions, a bunch of guys in Canada got around a table and had a beer and said, let's do this, okay? And they made up some rules about what involves malingering, okay? So if you get below chance responding, you're familiar with the idea of below chance responding, you get a forced choice test, go below chance. It's not 95% likelihood, it's definite malingering, okay? But if you get 2 positive scores, again, just by counting, then you're probably malingering. Now, what's the problem with the SLIC criteria? Well, as I'll show you today, I hope you understand that you have to look at the whole context of an evaluation. It's not counting how many positive scores there are. But the SLIC criteria have never been validated. You just have to hold up a DSM at the, say, how much did the DSM pay to validate these diagnostic categories? Even badly, okay? They paid $25 million. Paid $25 million to make DSM-5. How do they validate the categories? They have study groups, they have They go out and say, do these criteria work? It's never happened for the SLIC criteria. Never happened for the SLIC criteria. Okay, just a little math. That was a joke from my family. Not sure that they got it, but okay. This is what I use for attorneys to explain how you get true positive rates and false positive rates. Is you have distributions of people. They don't understand the word distribution unless you say distribution of income, okay? If you say distribution of income, they get it, okay? But if you just talk about distributions, you know, you just have to show them pictures. Look, there's all these fakers over here, and there's all these non-fakers over here, and there's some test score, it's a low test score or a high test score, and I'm just gonna make some decision point. It doesn't matter where you make the decision point. There's gonna be people from both groups that you catch. There's no way around it, okay? There's no way around to eliminate the false positive rate. If you want a higher true positive rate, you want to catch more people, you have to live with the fact that you're falsely classifying people in other ways. Okay, so this is the TOM. The TOM's a very good test, a test that I recommend to folks. And you know, the true positive rate's something like 48%, and the false positive rate's very low, about 2%. You can then just see what happens here to get this likelihood ratio is you're just looking at all the people that were caught by the test against all the people that shouldn't have been caught, and you say there's 24 times likely to be in this faking group. I would just add this for people who are interested in base rate. The idea of odds inherently includes the idea of base rate. Odds are a base rate statement. Probability is not a base, well, I guess it is a base rate statement, but you know, the base rate is already in this information when we're looking at it. So I get this odds value, not an odds ratio, but I get the value of the odds based on the characteristics of the test, the true positive rate and the false positive rate. Okay, so let's just show you again an example. If I'm repeating myself, it's only intended to be for your benefit, okay? Is to sort of crystallize this idea. I start with some value for the pretest probability of feigning 0.4%, 40%. That changes into a pretest odds of 0.67. I'm going to multiply it by a positive likelihood ratio because they failed the TOM. And then see, odds can be very large. This is what always throws me off. How can that be correct? But it is correct. That's the post-test odds, 16.08. Okay? How do you change it to a probability? It's very easy. You just add 1 to it and divide one by the other. So your post-test probability is 0.94. Okay? So that's a great test. Do you see how much confidence you have if you give one test? What's the probability? I mean, what's the problem? The problem is that you could get a negative score, right? How many people know that the Boston Globe, printed articles about how to defeat the TOM? So much so that Multi-Health had to send a letter to all of its users and say, by the way, the Boston Globe just told its audience how to defeat the TOM. And the TOM can be defeated. It's not a hard test to defeat, but in general, it works pretty well, and what's really great about the TOM is so fast, right? So fast, doesn't take up a whole lot of time. But a negative score doesn't change the probability much at all, and so you might say, maybe I need another test. Okay, now I just want to stop and just talk to you just for a second about this complicated graph here. But this is how a test works. This is the relationship between false positive rate and true positive rate. When a test, this is base rate. When the base rate is 0, you look at the proportion of positive scores, it's 2%, okay? So this is the false positive rate of a test. This is the true positive rate. When everybody is faking, 48% of the scores are positive. And what happens here is as you go along, this curve, then what happens is changing ratios of fakers and non-fakers, okay? As you add more and more fakers to the group, what happens? You get more and more positive scores, okay? The nature of the TOM is such that when there's about 20% people when 40% of the people are faking, only 20% of the scores will be positive, right? Because almost nobody is a false positive. And I just want to show you that that ends up with the same values that we got doing this likelihood ratio analysis, okay? So 0.94, 0.26, 0.94 for the positive predictive power for people who are familiar with that term. That's what we end up with the post-test probability is a positive predictive power. And then when it's 0.26, the complement of that is 0.74. The probability of a negative score means 74% likely not to be faking. Okay, so a negative score is not as helpful. Now, to end up my talk today, I just want to talk to you about some things that show this problem in even a different way. And so if you take the 24 tests that the person gave, you can go out and find the true positive rates and false positive rates for each of those tests, right? You can put them in an Excel file and you can run a simulation. That simulation is like a 100 megabyte file. So if you want that from me, I'm happy to share it with you, but you'll have to get a Dropbox account and ask me to share it with you, and we'll just load it that way, okay? You can go in there and just put all the values for your test in. You can simulate it, and then the question that I ask Excel is, how many positive scores are there by group? So you tell Excel, simulate a situation in which 40% of the people are faking, 60% of the people are not faking. How many positive scores are obtained by those individuals? 24 tests, based on the characteristics of the test. This is the distribution of people who are faking. And what I want you to know is that nobody that's faking gets less than 6 positive scores. Okay? So what's this idea of 2 positive scores being a cutoff? See, the person that I evaluated, or I didn't evaluate, the person who reported I had 2 positive scores on a test. Which distribution does that person belong to? Nobody that's faking gets 2 positive scores when they're given 24 faking tests. Okay, so this is a very powerful distribution to draw. I took it to court in this case, took it to a Daubert hearing, and what happened to the neuropsychologist? The neuropsychologist's testimony was excluded. Okay, he was allowed to testify. This was the funny part to me. He was allowed to testify about impairment only. The court decided he was qualified to testify about impairment. He wasn't qualified to testify about faking. Do you think the insurance company was interested in his testimony anymore? No. They don't want somebody to come to court and talk about impairment. They want to come talk about something else. Okay, but that was the distribution, and I just want to say that the way that I think it ought to work is this, is you ought to make these distributions based on the tests that are obtained. I'll be glad to share with you my Excel file that makes these distributions. I'm happy to do it. And you see, all you're really looking for is the 5% error rate, right? You can easily discover what the 5% error rate is by making this distribution and see which percentage of people are less than some value. And here you see none of, if you go this high, your false positive rate is going to turn out to be almost 0. Okay, so how many people are familiar with the idea of family-wise error rate? Alphawise error rate is what some people would call it. And this is why when you do an ANOVA and you have post hoc tests, what happens? You have to drop the alpha values of your post hoc comparisons, or else you're going to have a terrible Alphawise. Your error rate's going to exceed 5%, experiment-wise error rate. So here's what I like to think about is that a neuropsychological examination is an experiment with many hypotheses. And to be fair, you need to have an overall error rate that is about 5%. Here's the same Excel program I've been telling you about. We'll compute the Alphawise error rate for giving 24 tests. I think it was actually 23 tests this person gave. The question is, what's the probability of at least one false positive given the nature of the test? 91%, 91.4. It's a calculation. It's an easy calculation. It's just this calculation. It's easy to do this calculation. And so what happens is, my simulation is very close to it. These two values are the same. The true negative rate is what you see there for what? No positive scores at all. Those were our true negatives. Everybody else is a false positive in the terms of any positive score. And this is what you start with. Any positive score, the probability 91.4%. And then what you want to know, what's the probability of 2 positive scores? What's the probability of 3 positive scores? 4 positive scores. I only know how to do it with the simulation. I don't think there's any computational way to do that. Okay, so I just want to remind you of this statement that I see all the time. Persons who exert good effort almost always score normally. No, they score like this. That's how they score. When you have a false positive rate with the test and you add another test with another false positive rate and you add another test with another false positive rate, it's inevitable that you're going to get positive scores. And so it doesn't make any sense at all to have a concrete number of positive scores that indicate feigning. Okay? And I'm going to tell you what I believe is true, I can't prove is true, is people keep giving tests until they get positive scores. I see it over and over. Why would you keep giving this test? How many people, fake bad scale is a big controversy, right? You can think about it what you want, but what I see people doing routinely is give fake bad scale plus 3 other pain questionnaires, all designed to identify. And they just keep giving them, it seems to me, until they get one that's positive, and then they harp on that one. It's just not a fair way to do evaluations. Okay, so I asked this question when we had a negative score on Tom, maybe we need another test. I just want to, there's so many tests out there. These are all standalone tests. Then you have embedded, tests of malingering, a whole chapter on them. Okay, if you don't know that chapter, just do a little research. It's a chapter you must have on your desk. Okay, so let's reevaluate our assumptions in this talk. Valid tests exist that classify the 2 groups with known error rates. Is this a good error rate for a test? 48% true positive rate, 13% false positive rate? Come on. That's just not fair. Okay, it's just not fair to use a test with that high a false positive rate. And when you're using a sample that has so few people in it and you find the standard error of measurement around those rates, the actual rates are something like this. So what we rarely see in our literature reported, and I'm very disturbed by this, is we don't see confidence intervals for what the error rates are. What should really happen is people should identify a point estimate, generate confidence intervals, and the next study should ask the question, is my value in this range or not? What would be ideal is if we just kept adding samples to make one grand distribution that we could use to get our cut scores. Okay, this is what I just said, and this is what typically happens. Researcher A publishes a TPR and FPR, then researcher B says, okay, by the way, researcher A found that, and this is what I found. End of paper. No way to bring this information together. And then what often happens is they use different cut scores than were previously used. I will tell you, if you want to look at the classification accuracy of the infrequency scale in the MMPI, you can't find more than 3 or 4 papers that have the same cut scores. The cut scores go anywhere from 15 all the way up to 30. And so this sort of thing, my Excel file, is pseudo-precision if you don't have good TPR, good FPR. So you remember what I said earlier, using his methodology, using his data, this is how it's computed, but I'm not saying that you can get precision unless you have good TPR and good FPR values, okay? Here's a good paper by Schroeder et al. On digit span. And what I think is one of the great papers, because what it does, it looks at all the studies of digit span and says, what ought to be the TPR and FPR of digit span? You see neuropsychologists all the time using a value of 7 or less to indicate faking on digit span, but that just is not supported by a review of the literature. 6 or less, and then they give good, reliable estimates of TPR and FPR. Grieve and Bianchini, I think, do some really excellent work in this area, and what they do often is they give you the whole distributions in their paper. So you can evaluate your own cut scores and see how the cut scores worked. Okay, assumption 2, the local base rates are reasonably estimated. If you use that, this test validation summary, which is on my website, it's on my website, you can download it. There's a lecture on how to use it. But look, when a test has a 10% false positive rate and 80% true positive rate, all you have to do is to look in your sample and say, how many people failed this test? What proportion did? If you do that, you can come across here and find out what the mixture is in your clinic. So you can start out with a good measure of P of F before you test anybody. It's not hard to do at all. Okay, the last assumption that's questionable is that there's 2 groups. And so I see attorneys all the time. They're not, they don't get distressed at all when the testing data show that the person is faking. So I'll say to them, well, look, you don't have anything to go on here. This person, I mean, the faking scores are against them. And they say, oh, well, but there's 3 groups. The person's depressed. They have amotivational syndrome related to a head injury. And these are tests of effort, right? They just didn't give very good effort, and I agree with you, because they have a TBI, they have amotive. So they go to the 3rd group argument. And I think this is a real vulnerability of neuropsychology, because they really haven't done construct validity in an effective way.